Hey everyone, I can't wait to start work today because for a long time I've been working on making the parts for the marble escapement gates, and I think they are the key to the future of the Marble Machine X. And in this box is the key to the escapement gates themselves. This is the Marble Machine X, a programmable music instrument using marbles to play music. Up until today, I haven't been able to put all this together, but with the contents of this box, I can put it together. Wow! This is another Marble Machine X delivery from Acecraft.eu. Last time, Ace manufactured the rubber wheels for the cyber base, and opening that box was a religious experience, and the rubber wheels actually helped me to play some Bach on the Marble Machine X. Let's have a closer look. It says MMX Wintergatan, reference 4402 axle. It's our part number on the box. It's the logo of Acecraft, and it's hinges. Let's try to open these up. Ooh. This is my life now. This kind of creativity makes me so happy. So let's see here. That's the 4mm circlet clips. That's the 5mm circlet clips. We have 5mm shafts for the cyber gates, and we have 16 4mm shafts. No, 32 for the escapement gates. So these shafts have been lathed by Ace, and as you can see on the ends here, you have these two tiny grooves, and that's for these circlet clips. The circlet clips will prevent things from sliding off the axle, and it's a very space-efficient way to do that. So this is some footage from the manufacturing of these axles by Acecraft. I'm really happy that Acecraft could step in because I don't have a lathe, and the delivery from Ace is always Ace. So that's a maker who lives up to the name, and Acecraft has made an awesome YouTube video for the Acecraft YouTube channel. So check out the Acecraft YouTube channel and send some much-deserved Marble Machine X love because the delivery is always top-notch. The small little notches that had to be cut in this axle are like super small and super tiny, and Ace nailed the tolerances. So thank you again, Ace, for being part of the Marble Machine X. So let's check the fit here. It's a little resistance, which is great news. I didn't want this to be too loose. There is some residue from the laser cutting preventing me from pushing this axle in. I'm not going to drill it open yet because there's some interesting idea of maybe using this as a press fit. But I've been thinking about how to getting these silicone bronze braced straight in, and me and Ace had the same exact idea. So Ace have made a jig here. So with this jig, we can put the axle into this lathe jig. This jig will keep the axle completely straight, and on the backside is an adjusting screw. So I can exactly adjust how much stick out. In this video, I'm gonna work with the 4mm axles. I just want to show you what the 5mm axles are for. They are for the cyber gates. If you can see these cool steel profiles, you can see that there's two round holes, and these axles are going to pass through these holes. When I started designing, I put a bearing on every moving part. I didn't understand bushing. Bushing for some applications is the better way to go. This is Delrin POM, and silver steel is what Ace used for the shafts. There's no friction in this fit, and most of all, there's no play. I can't, I try to move this axle sideways. I can't, okay? So there's no friction and no play. So I'm gonna put these 5mm axles aside now, and that's for a later episode. I have 5 alternatives for how to put this axle in and make it stick. The number 1 alternative is using nothing. The idea is to let the parts themselves hold the axle. And when the axle is full with parts, the parts should hold it straight automatically. The next solution is to use this press fit that comes from the laser and just whack it in with a hammer, neatly, of course. So the next solution is to put the axle in at the correct place and then use some metal tool and beat some notches around the axle. And this is an idea from Ace, and this is widely used in clockmaking. I never did anything like that, but I understand the principle to deform the metal around the shaft and kind of hug it. The third idea comes from Acecraft's dad, so shout out to Acecraft's dad, who said Loctite will probably be very strong in this application. So if I drill this hole clean, I could probably Loctite it. Perhaps Loctite in combination with the clockmaking notches could be something really cool. I will weld these parts here. The part will be heated up after this, so I don't know if this heat will actually interfere with the Loctite bond. That might be an issue. The last and strongest alternative is silicon bronze TIG bracing. This is what I plan to do all along. I know this will hold up forever and it will not be affected by the welds. It is a little bit scary, but it's the absolute correct method because, as I said, these axles are silver steel and the profile is stainless steel, and silicon bronze bracing is the perfect go-to method to glue together different alloys of metal. The silver steel axle is pretty undersized, 3.982 millimeters. So I'm going to try with the first one to just whack this axle into the laser residue and see what happens. So let's try to just use some brute force here on these beautiful parts. This is an educated decision to use brute force, okay? Oh, okay, I'm lucking out here. So there is a little bit of play there. It's almost perfect. Here's the left side pallet, goes on this side, and here's the right side, goes on the back side. Okay, so the fit seems pretty tight here. There is a tool called reamer. A reamer can kind of enlarge in a hole from within, like an expanding drill kind of, to make a hole to a very precise diameter. Often when I want a precise fit between an axle and a thing, I'm using the axle itself as a reamer. I don't own any reamers. Also in this case, Ace has cut this notch here, and this notch is kind of sharp. So I think this will work great. So I'm gonna put the axle in my drill, and I'm going to just enlarge this POM part. There we go. Perfection. Literally no sideways play and literally no friction. If I take a 4mm drill and do the same, I won't have that good fit. Awesome. Let's add one more washer. So 4 washers. Let's do the same on the other side. So now I can use this specialized plier to expand the circlet clip and put it on. Wow. Okay, I'm excited again. It's kind of exhausting to be excited constantly about this machine, but this is fantastic. So the tiny clip there, holding everything in place. No friction, and parts seem pretty stable. I can rock this back and forth, and you can see this play here. I can minimize this play by welding it, but perhaps I don't have to. So let's start looking at the parts that go on this front axle. So this is the exploded view of what goes on this front axle. 2 mirrored gears on the side, and then these PUM parts and the profile in the middle. I just received the bolts for this. Sourcing material is the least fun part of this whole project. I hate it. I'm so impatient. When I want something, I want it right away. And I ordered the wrong screw. So I ordered 16mm because I was sure that 20mm would stick out. But if we measure this, we see that 20mm flathead bolt will be the perfect length. Need to go and order those. I'll be right back. I'm gonna manually shorten 8 screws to 20mm so we can assemble this today. I have noticed that whenever I use a machine screw like this and thread it straight into like another material than metal, like wood or plastic, people get a little bit nervous about the hold strength of these screws, but I can reassure you that this works brilliantly. I feel the resistance here, and just because this is not like how things are done conventionally, doesn't mean we can't trust it. I've designed these spokes to be right at a peak of this wheel, so we have 2 marbles in the openings, so kind of like this. The gear is not sliding on the shaft, it's binding, so we need to ream this up, and I'm just going to use the drill press and the shaft to do that. So I'm trying to move the axle, and it kind of doesn't move at all, but look at the frictionless. So if we look at sideways stability, you can see that the gear is super straight. The brass is not touching the axle. That hole here is oversized. So it's the PUM bushing material that is touching the axle. There is not a single step where the brass wheel can freely rotate, because if I just go where this little peg is letting go of the wheel, this peg is already inside the wheel. So check this out. Just letting go there, this peg is already stopping the wheel. So there's no fail state. When I designed this, I left a little space in the middle for the weld tack. So I have a little play here. Don't think it matters. And now I have a very important decision to make. Is it okay that the axle is moving ever so lightly? So the accuracy of the gate is important. We don't want the marbles getting stuck because the axle is moving, but I think it doesn't move enough to get the marble stuck. So I don't really know what to do, but I know that I am epically satisfied about how this is turning out. It's the best thing I've ever built in my whole life. Yeah, I'm going to do something to stabilize this axle. I actually don't think it's necessary, but if we can get the precision and tolerances higher, why not do it? So I'm going to take this apart and start stabilizing the axle. I'm fretting over this decision now. Maybe I'm changing my mind again. It's like, you know, a design should only be as stable as it needs to be. So if we look at my analogy with the 4 wooden sticks, where the design purpose is to have the wooden sticks standing up. Good design and engineering is about choosing a good enough solution, not maybe the most stable. That's like over-engineering stuff. And perhaps this little movement of this axle is a feature and not a bug. And it reduces a welding operation where things can go wrong and stuff. No process is the best process, right? So I tried leaving the axle loose. Now I want to try the clock-making method of making a divot. So I'm now going to use this jig. So let's figure this out. So first of all, the length of the axle is 54.7. So now I want to know the middle of the shaft. So then we're going to divide that by 2. 27.35. And now we need to subtract the thickness of the metal, or half the thickness. The metal is, as you can see, 3 millimeters, 27.35 minus 1.5. 25.85 is our value. Now I need a way to clamp this to the profile. So I made this little bracket here. That gives us room to put clamps like so. So with the backside of the caliper, I can met the distance the axle is sticking out from the jig. And here I want 28.85 and it's 33. So I'm putting the screw backwards. 28.90, very close. 28.82, close enough. Now I can take this adjusted jig, push it over here. And this should be this number, 25.85, I wanna see now. 25.88. Okay, we're doing well, we're doing very well. And this piece is lathed perpendicular, so this should be completely 90 degrees in all angles. So this is a spring-loaded hole puncher. I'm going to try to punch next to the hole to deform the stainless and clamp the shaft, clockmaker style. Here we go. Will this work? Okay, you know what? I'm just gonna tap this instead of the clamp on top. Ooh, there's a little divot there. Putting the second one at opposite direction. I went all around. Let's uncouple this and see if this worked. It looks straight like this and straight like this. I can't move it at all, but the most important is it's sitting in the middle. 25.88. Let's go over to the other side. 25.84, 86. And I would say this is a huge success. So I made one side of rivets. I'm going to also rivet the other side. Divot. I don't even know the name for it. The second side I did looked much better. I'm stoked about this method. So thanks Ace for suggesting a clock making method for fastening this axle, only fitting for a clock escapement gate. This is how I'm going to do all 15 gates. I bolted the second one in place as well. This looks good. So now I can move all the moving parts from this loose axle that we're still moving to this divoted, stuck, steady axle. So on this axle, I had a little bit of play. So I'm going to try to use very thin shim stocks. These are the timing shims for the marble snakes. 1/10 of a millimeter. I'm going to cut like a shim washer from this. Then one normal washer, my shim washer, another normal washer, the gear, and that looks really great. The wheel is not spinning as smooth as before. I think I scratched the silver steel axle when I pushed it through the press fit. I'm going to try to sand it a little smooth again. Yeah, that's better. 2,500. Super fine. There we go. The last circlet clip is on. And yeah, this feels amazing. There's no play sideways at all. Perfect play like this. Everything is moving freely and will stay where I want it. So thanks Ace for not only making amazing axles, but also suggesting a really cool method for attaching the axles to the steel profile. This is ready for welding. So the marbles are riding on this rail here, like this on both sides. And I cut this notch here so I can put a silicone tube in like this. Silicone tube is on and the tolerance is perfect. The POM is not rubbing against the silicone in any position. And so the marble is running on this silicone tube and is being forwarded by these gear like this. Next steps will be to prepare these rails that goes on to the gate like so and so. So I have some post-processing to do. I need to design some jigs, so I make sure that I weld everything together at perfect positions. Designing these jigs and welding this together will be the subject for next video. For now, I'm so happy for these axles from Acecraft.eu. Fantastic work. This is turning out great so far. Funny thing is that we still don't know if this works. It looks great, sure, but will it work when the marbles pass through? That remains to be seen. So thanks to everyone who's supporting this project through YouTube memberships and through Patreon. Thanks to everyone who's watched all the way to the end of the video. You are awesome. And thanks to Wilson and Bling Wilson for... Where have you put POM Wilson? Ah, there he was. He was playing hide and seek, so gears are best friends forever. So I just hope that me and the Escapement gates also can become best friends forever. Let's see how it goes. See you in the next video. Have a wonderful day. Bye.